this practical lab is a continuation, basically, of our tutorial yesterday. Yesterday, we were focusing on a TikTok data set and on how to visualize, the viral takeoff of a TikTok meme using image plot macro of image J. Today, we will further experiment with some alternative visualization techniques using image J and raw graphs. We will also use the same data set. Please, Katrin.
Yes, I wasn't attending yesterday. Is it okay if I stay here, or is it better to go back to the raw graph?
Yeah, no worries at all, because
Okay.
we will start from scratch. It's not mandatory to attend both workshops, but it's just for the background. I think Anna, Sophia were there yesterday.
Okay, thanks. Perfect.
Yeah, just as an intro. So all the important information for you is in this folder, the slides, then this particular folder is quite important since this is where we will be working, and I would suggest the same procedure as yesterday. This one is a spreadsheet that we will be actively working with, so please create your own copy of this spreadsheet, call it by your name, and it will be your personal workspace. This second spreadsheet contains already all the steps and all the, kind of spreadsheet files that we are going to create in order to visualize our data. So I just call it cheat sheet. You basically can switch back and forth between the two. So no fear of missing out. Everything is already in this one sheet, then also in this walkthrough. So this is the walkthrough we started to use yesterday, and I extended it with one bonus analytical step for using raw graphs, and this is an analysis that we are going to perform today. For those of you who were not attending yesterday, it's quite important, while I'm making the introduction, please make sure that you have downloaded this folder, TikTok image folders plus measurements, because we will be working with a particular folder of images. And if we will have time, we will also work with another folder of images that you also might want to download. But the most important two folders are measurements and this one, TikTok board in the house, containing 1,800 something images. Okay, so this is the basic intro for you to make yourself familiar with our data set and with everything you need for this practical lab. I think I see two comments in the chat. Let me just check. Oh yes, perfect. Anna is assisting beautifully as always. Thank you. So yeah, let me just introduce you to some conceptual stuff regarding memes. Important for us as a starting point is an understanding of memes as engaging content and as data-intensive objects of cultural production, right? So images as data objects and at the same time objects of cultural circulation and appropriation. Why is this interesting in terms of meme analysis? First, because memes are designed for circulation, for appropriation. They are always already a collection of images. So a meme is never an image in itself, right? It's always a whole mimetic environment, if you want so. Then memes are also multi-layered, right? In that they often merge visual, textual, and auditive features in one digital artifact. So on TikTok, and we will be focusing on TikTok today, memes are dynamic, moving images. They are like audio-visual memes in a way. But much of, let's say, traditional mimetic content is template-based, which can be interesting both in terms of fixity and flexibility, as it is the case with, well, Dodge meme, for example, right? Other memes, though, are more context-specific, I personally, I am more interested in the latter. So I'm interested in context specificity and in the transformation of memes across different contexts and scales. So finally, memes are also dynamic objects that transform as they spread across their multiple sites of circulation. And this includes platform-specific and also cross-platform hashtag publics. But then again, also wider environments of the web. We know the internet is, let's say, a subject to platformization, but there is always more than platform environments. So different image domains, different sites of image circulation. This is what we need to keep in mind conceptually. And if you see like some references, they are also links. So if you click on them, you basically will be redirected to the articles that might be of interest. So yes, conceptually, memes are enacted within networks, collectives of images. They are shaped by the multi-sided cultures of appropriation, and they are embedded in platform infrastructures of use. Methodologically, so this has consequences methodologically, right? Especially when we explore visual content as part of platform infrastructures. We explore memes as, let's say, as transversal. I even wrote it out as transversal data objects. What does it mean? It means that we need to account for their engaging qualities that register through acts of liking, reblogging, linking, sharing. We need to pay attention to hashtags, time of posting, actors and domains that assemble images, making them relate to one another. And then we might want to synthesize this platform driven metadata with internal image features, such as, for instance, color arrangements, hue, saturation, brightness. These features can be calculated, right? And this is what we practiced yesterday using the measurements macro of image plot. But then there is like also image content. And this obviously can be interpreted by us through different qualitative methods. But images as data objects are not only human readable, they are also machine readable, right? And some content features can be extracted from large image collections using AI-driven techniques of tagging that we can access through different platform APIs. And yesterday, Anjana gave a practical lab on doing precisely that. So I think it was a practical lab called Enriching image collections with something, using Jason's Memespector. So yes, finally, depending on your research question, depending on what you want to explore, you might want to use different layouts for arranging your image collection in space. And yesterday we practiced two image plot techniques by arranging the images in accordance with the time of posting and their visual style. The purpose of this technique was to explore the viral take of the spreadability and the rhythm of posting behind a particular TikTok meme. Our case in point today and also yesterday, it's a sound meme by Curtis Roach, a sound meme that became a hashtag. Curtis was bored in the house during the first wave of the pandemic. He posted this video of him rapping, snapping fingers, drumming on a table, and his song, along with this gesture, it went viral on TikTok, right? So this sound kind of assembles more than 3 million videos. This produced this virality of a TikTok gesture, of a TikTok sound, produced what we might call TikTok imitation publics. And again, here is a very interesting recent article on that in New Media and Society. So, and these TikTok imitation publics have multiple layers, as I've mentioned: visual, auditive, interactive, and we will explore these layers as mediated through visual content, its temporality, and its mimetic hierarchies on TikTok specifically. So today, what we will be first looking at is how to capture the dynamics of imitation through visual content. And to do so, we will be using the same TikTok dataset as yesterday, with images that were labeled by Google Vision API access through Jason Chow's Memespector. And we will visualize it using an image montage technique, so a different technique from yesterday. In the second step, and I think it's quite interesting to see the same relations in a different way. So in the second step, we will use raw graphs to analyze our data set in terms of mimetic hierarchies and associations as mediated through both image content, but we are not going to show the images, image content, and then in relation to co-hashtags. Yes, and I'm going to come back to this points in a bit. And finally, if we will have time, we will be focusing on how to capture mimetic gestures by deconstructing 10 most liked boards in the house videos into a sequence of image frames using the command line tool of FFmpeg. So every step in this tutorial, as I mentioned, is documented in this written out walkthrough. And we are going to reproduce the main steps, basically. So yeah, no FOMO. Yes, we will start with our first technique, and it focuses on content similarity within specific time frames. And in order to get to the patterns of similarity in image content, all of the videos were pushed through Google Vision API, accessed through Jason's Memespector client, right? In this image, so it's just an example so that you understand the logic of Google Vision API at work. In this image, Google Vision API recognizes different entities labeled across a broad group of categories, like you see body parts, objects, textures, the so-called Google Vision API labels that are based on, pre-trained image recognition algorithms. Then Google Vision API also recognizes some contextual information, which can also be updated, obviously, because the image is not stable, right? This information contained in Google Vision Web Entities is derived from the communicative environment of the image based on the information provided by the Google Knowledge Graph API. And just to give you an idea, what Google Knowledge Graph does is, so, we Google Curtis Roach, and then we see here all this information and also like stuff like some recommendations. People also ask who invented boards in the house. So this kind of information. And this is what Google Knowledge Graph API is responsible for. And it draws and updates its information partially from the text attached to the image, from the image captions on sites that Google prioritizes in terms of ranking. So this is why quite often in web entities, you will see sites such as YouTube, or if you are like working with typical meme templates, you will see Know Your Meme, for instance, right? All these feeds into this mode of detection of web entities. So labels are entities contained within an image. Web entities are in a way descriptions, tags contained in the image environments. Well, and then Google also recognizes exactly the same image, a full matching image, on a series of other pages, obviously several times on TikTok, YouTube, Facebook, right, Giphy.com. So it kind of points us towards acknowledging the spreadability and the multi-sidedness of the image in question. For our purposes today, we will be working with Google Vision API labels only, and I will explain you in a bit why. yes, maybe I think I'm again sharing only my my browser. Let me stop sharing, and I will share my whole screen. Yes, now it's better, right? Fantastic. Okay. So yes, let's just start and go here in this folder and start working with our boards in the house original scraper output. Right, that you might want to copy as Sophia just did in order to work in your own spreadsheet. So yesterday we already performed this step, but it's important for everyone else attending. Each time you start working with an image data set, you really want to organize it. And my preferred way of organization is the temporality of posting. So the TikTok scraper gives you this spreadsheet output, and one of the columns is create time, which is a timestamp. So yesterday we were working with timestamps to visualize images through image plots. Today we will be working with image montage, and it requires timestamps are are machine readable time. Image montage requires human readable time, which we also might want to have a look at in order to understand when did this particular image go viral. So in the walkthrough at the beginning, for those who did not attend yesterday, you will find like a workaround or like a step-by-step tutorial to creating this column, so creating the human readable time column. You just open the Epoch batch conversion tool, you copy and paste your timestamps in here, and you output, you convert the timestamps, and the tool, this online tool, gives you a .csv, so a spreadsheet output containing just one column. And this will be this column human time, so something that we can also read. Then what I also did, and what I recommend you to do in order to create an image montage is, so this is how an image montage looks like, and it requires you to specify like a top and a sub layer indicating a specific category. In our case, it will be time. So, and as you can see, the top layer is the year and the sub layer is the month. So this is why we created just manually. We created a new column indicating the year and indicating the month. Okay. So the next step that we need to work with our images is obviously to download the images. And again, the logic of downloading will be the logic of temporality. In the walkthrough, you will find the step-by-step explanation of how to download the images using Down Them All extension for Google Chrome. And in this image folder, here, you will find all the images already downloaded for you, the images that we will be working with right now. From this folder, you will copy and paste all the file names of your images in a new image column. So, and the numeric order will correspond with the logic of time. If you work on Mac, it's just opening your let me see. Oh, I'm maybe already in here. Yes. So you will just open your folder of images. You will just select all the images, click on Command C, so copy, and paste it to a spreadsheet. If you are working on Windows, you will need some in-between steps in order to do so. And these in-between steps are documented in this YouTube tutorial. So this is the history before or the story of this data set, all the steps that you need in order to arrange it according to the logic of temporality. As soon as you have your folder of images, and as soon as you have this image column, we will need like another analytical step, because we decided that we want to analyze the images by the similarity of content. And for this, we will need JSON's Memespector tool. This is why one of the requirements for attending this practical lab is, in the best case scenario, attending Jason and Shanna's tutorial from yesterday, a tutorial on invoking Google Vision API and other Vision APIs through Memespector. But it's really very, thanks to Jason, very easy to use. So you basically invoke the Memespector GUI, and you ask it to analyze a folder of images that is locally stored on your computer. So maybe I will just quickly show it. I will not run the images because I already did so. My computer is rather slow, so it takes time to, yes. So this is where you can specify your Google Cloud credential file. This is everything that Jason and Jana explained yesterday. And then you have some options on your image locations. So I prefer to add images from a folder on this computer. So you just open it and ask Memespector to run it. And this is what I did. The output is this spreadsheet that you hear, that you see in. Let me rearrange Zoom. Great. That you see in this spreadsheet number 2, board in the house, analyzed scraper output. So Google Vision data. Yes. What you also might want to know, just as yesterday, Google Vision creates an output, a spreadsheet output, but the order of images, it's all messed up. So it's not going to return you the order of the images like in the numeric order. So in order to make this work, and make the descriptions of the images correspond with the right image files, you will need to sort your data. So you will create a new column, copy and paste these image base names, and then by using edit, find, and replace, you just search for .jpeg, replace with nothing, replace all, and it will give you just the image numbers, which you will then sort from A to Z, and it will give you the right order. So, and we had the same problem yesterday when we arranged the measurements made by image J. So finally, everything is in the right place. And well, we might want, so these are like all the image recognition options of Google Vision API, which are all quite interesting. But again, they go hand in hand. The way you use them, it really should correspond with your research questions. For our purposes, we will focus on the label descriptions. Because what we are going to do right now, we just copy this column. So maybe indeed make sure that the images are in the right order. And we then just copy this label description column in here, right next to our maybe. So these were the image URLs basically that I used, that are already expired and that I used to download the images. But we just copy the labels right next to image number. Okay. So as soon as we have done so, yesterday we kind of found out by using our first visualization technique, this meme went viral, really, this hashtag, this audio meme went viral in March, April, and May. So my suggestion would be to create this type of visualization would be to focus on just these 3 months of, you know, the viral takeoff. So we will now be working with our spreadsheets. We will create 3 new sheets for March. Let me just rename it. March, April, and May. Yes, then we will filter our data by this particular time frame. So we just go select the column human time, go for the option, for the filter option. Here it is, create a filter, and ask Google Spreadsheets to filter by condition, text contains, and we just go for 2020-03, so March, and click OK. Okay, and then we start copy and pasting. So a lot of work that we will be doing is happening actually in Google Spreadsheets, because this is where you prepare your data for visualization. And then we will just repeat this step and go for April. Click OK, select. Copy and paste. And repeat the same procedure with May. Okay. Select. Copy and paste. Well, then we also want our main row everywhere, and we freeze it in order to be able to sort our data later in the next step. Okay, so now let's start with March. And what we want to do now, so we are interested in the similarity. So now we basically defined our time frame. So the time is already encoded, so to speak. Now we want to arrange our images by similarity. We now will use the column that we just created, the column label description, and just sort it from A to Z. And you see, well, we already see like cats, clothing, dogs, faces, food, and so on. So with TikTok, it's really, as you can see here in this visualization, TikTok is very much dominated by faces, bodies, and gestures. So many images will be like focusing in terms of Google Vision labels, will be focusing on facial features, forehead, hair, and so on. But well, some of them will be having other features like, you know, wood, for instance, that will be interesting for us to look at, because, you know, wood translates into all the tables that people use to, you know, imitate Curtis Roach. So good. Yeah, let's just continue. So we already arranged March. Let's do the same for April. Sort sheets from A to Z, and for May. Okay, so now we want to merge everything in one spreadsheet, and we will just use March as a starting point, since it's the first month that we are going to, the first time frame that we are going to visualize. If you see something like this, it means that Google Vision API was not able to recognize what's in the image content, maybe because it was blurred, for instance. So just leave it like that. Okay, so now we just copy April that we also already arranged by similarity. Copy April to March. So this is just really, and make sure that you start with the right column. Okay, and then copy May to March and April, and then our data set will be complete. So add some more rows. Okay, here we are, and copy May. My computer is a little bit slow, sorry about that. Okay. Good. Here you go. So this is now our spreadsheet that we can use as an input to work with image montage. So here You see montage, time, content, similarity. What I did here, I basically just deleted all the information that we do not need for this visualization. So here I just left human time, month, year, image number, and label descriptions just for us to check later. So then you download this file as tab separated values. This is the format which is readable for image J. Okay. I already downloaded this file. So it's here, and you also already have this file. It's here in the measurements, and it's called montage time content similarity.tsv. So now let's open image montage. I again must rearrange my screen here. So let's open image montage by searching for image J first, opening it. Might take some time for it to open. Yes, and let's activate image montage by, and I'm sorry, just for you also to check. The thing is, you might have image montage macro already in your folders, but I am not sure whether it's the most recent one. So I shared with you the most recent one in our folder, image J meme analysis. If you click on download image J image plot master, it will open, and please just download this .txt file. This is the current version of image montage that will allow you to visualize the images. Download it and please save it somewhere where you can find it. So I save it in the folder image J macros. So here is where I saved it. Okay. Are we good? The file is saved. Perfect. So now, yeah. Now let's activate image J and go for plugins, macros, run. Yes, look for your image J folder. Look for macros and look for image montage. It's not make montage. For some reason, it's not appearing. Just let me check. Maybe I have to start it again. Macros, run. Yeah, here we are, image montage.txt. Okay, so and then just open it, and it should result in all these options that we now will specify. So we will specify image source, and it should be a data file. You will also find some screenshots in our walkthrough, where you will see the specific settings. So it's all related to image plots, and here you see the settings for image montage, just for better orientation. Okay. Yes, so image source is data file, and then we will specify the width and the height of our canvas, and adjust it in order to make the images bigger. Just use these.
Sorry, Elena, it was 1840, the width.
Oh yes, this is what I was going to explain right now. So the width that we used yesterday is like a smaller format, right? And we want a montage, and we want to zoom in. This is why I would suggest we use these measurements. Okay. Yes, then as soon as we have the width and the height, we can then specify the size of the images. And here I would recommend for 80, to opt for 80. You can also specify the spacing. And the spacing, you know, it's an aesthetic decision. Basically, if you opt for 0, the images will be very, very close to one another, which is very good sometimes, so that you can compare better. But you know, you can also opt for 1 or something. I prefer to go for 0. So then the number of labels, and the number of labels stands for these headers, for you know, the top level and for the top level description and the sub level description. So we use 2 levels, and specify also text size, and we have like the size of the images is 80 pixels. Let's use here something like 70, but you can play around with it. Text color will be gray, so this is why it's set in the middle of the scale, and the background's color will be white. Okay. If you want to play around with it, you can save images for animation, but we don't want to make everything slower, so I would not recommend doing it so right now. So yes, click OK. Then image montage will again ask you to specify the file that we want to analyze, and to specify the image folder that we want to run our analysis on. So let's look for our image folder and the file. Yes, in this case, we are in our meme analysis folder. This is the folder of images that we are going to look at, and we are just opening it. And then it asks you to specify the measurements, right? The .tsv file. And we just, again, look for it. And it should be montage similarity montage, time, content, similarity. So each time you perform this type of analysis with many in-between steps, I recommend that you try to organize your data in a way that is recognizable for you. So, and I'm very unstructured. This is why I kind of try to name the measurements that I'm creating in accordance with the actual analytical categories I use. So in this case, similarity and temporality. Yes, and then just open. And Image Montage will ask you to specify the file path. And in this case, image file path, right? It's our image file names, which were named and downloaded by the logic of temporality. This is why it is called time. And then it will ask us to specify the top level category label, and it's the year, and the second level category label, which is the month. Okay, and click OK, and let's hope it works. Yes, so now does it work for you? Wonderful. I'm happy if it works. So it's always like, yay, an achievement. Yeah, but just because there are so many steps in between, and sometimes you might forget. So yes, now Image Montage is plotting our images. And as soon as it is done, we will be able to zoom in. But we can already see, like, here are our cats and dogs. Then somewhere else, we will see like images focusing here, bananas and some food. Obviously, we see like a lot of faces, and this is what I would actually call the specificity of TikTok vernaculars. They are very TikTok imagery is very gestural. We have a question, please, Anna.
I have a technical issue. When I try to use Image Montage, I cannot click OK. When we chose like color mode, images, like labels, I'm still on this stage. It doesn't show me fully to click OK or cancel.
Okay, it's in this case, maybe you missed one of the in-between steps. So I would propose that you go back to the walkthrough and just repeat the same steps from scratch. Unfortunately, Gephi, ImageJ, they do not allow, to just refresh. You really have to go back and start everything from the very beginning. But I'm very much sure that it's just, sometimes you click, you select the wrong folder and click OK, and then it's all messed up, and you need to go back and start from the beginning. Okay. So please just repeat the steps, but it should be working then. Yes, so here we are. Image Montage is done, so you can zoom in and out of it, make screenshots. You can export it, save as, and then save as I prefer PNG. Well, what I did here is well, a sort of very simple, not very aesthetic, but still analysis. So I just highlighted the areas of Image Montage that have visible repetitions, like images focusing on pets, on food, images of wooden floors and tables that people use to imitate Curtis Roach and, drum and knock on wood. And yes, as I've mentioned, we are using a TikTok data set. So the main pattern, not unexpectedly, involves the images of bodies, faces, and gestures, confirming TikTok as well, this newcomer of the gestural web. So we usually address, Giphy.com. This is like all about gestures, but TikTok is another example. So yeah, this is one way of analyzing images. And now I want us to create actually something else. Yesterday we started to discuss like some ethical issues also of, which images do we want to visualize, which images do we actually want to show, as Kathleen mentioned yesterday, it's always question driven. And, every time you work with visualizations, and especially every time you work with zoom ins, just consider, checking whether accounts in question actually pursue virality. And how do you check on that? You could look at the hashtag combinations and whether they are designed to maximize spreadability and searchability. And we will check this by looking at some co-hashtag relations on TikTok. So on TikTok, everyone kind of wants viral fame, but not everyone gets it. Yes, you could look on the tonality and stance of the actual post captions. And you can consider at the end maybe an alternative way of visualization, focusing on Annette Markham's suggestion, which involves transfiguration of original data and alternative formatting of data, like here. So here what you see are 3 selected co-hashtags that were used frequently with the main hashtag boards in the house. And these hashtags correspond not only to the main hashtag, but they correspond with the actual sound. So what we are going to do now, and we have 30 minutes, we are going to yes, to our original data set again that we just analyzed, and go to here our whole data set, and maybe select or create a new sheet, and then filter everything by the sound meme. And on TikTok, you can do so by using this column, which is called music meta, music name. And this is where you already see boards in the house. So I just select and copy it, because I I want to work only with TikTok videos attuned to this sound. So again, I filter this column and filter by condition, and click on text contains, and use boards in the house as input, and click OK, and copy everything in a new sheet. I again freeze the first row. and I call these sheets just, sound, in order to know, okay, we filtered our data set by sound. So then there is like one thing that I want to share with you. When you scrape your TikTok data, the original scraper output does not involve an extra hashtag column. It just comes with the text column. So how do you create a column that contains only hashtags? In the walkthrough, I shared with you here in our bonus, I shared with you this formula. It's a regular expression that allows you to trim everything that is not connected to the hash sign, therefore extracting the hash signs. So you just copy and paste it in here. So I mean, I already created this column, but just to show you. So basically, this is the column where you create your hashtags from, or extract your hashtags from. Insert one column, call it hashtags, maybe, and use this column and, you know, specify, use this formula and specify the column. So in this case, it's not A2, but C2. Okay, and then just go push enter and suggested autofill. Very handy. Thank you, Google Spreadsheets. Just yes, enter. Say yes to Google. Good. And well, but now you see it's a formula and you want it as values. So what you do, you just go on copy, and then you do something else. You go for paste special and use values only for pasting your hashtags. And now, as you can see, it's just text, which you will need to work with your data. So delete the column. This is our list of hashtags. Good. So now let's start exploring. So what do we have? What do we need to create a raw graph visualization like this? We need first the main co-hashtags, and you can specify them as you please. So I decided to go for quarantine, comedy, and dance, but you can also go for cats for off TikTok if you want. It should be fun. So let's just. But how do you make this decision? You actually explore. So you select all the column hashtags. You go to tag crowd, which is a very useful but simple word cloud tool. You paste your hashtags, select the maximum number of words to show, which is 50. The minimum frequency, let's say maybe 5. Show frequencies, yes. And you know, you don't want to show obviously one word, which is board in the house, because it's our main hashtag. And then just go for visualizing. Okay, and then you can, you know, select the hashtags that you want to analyze. So I selected quarantine, comedy, and dance. As you can see, it's not like the preferred hashtags. I did not select for your page and for you. I selected something more contextual. So, but you can experiment also with other main co-hashtags. And now what we want to do is to create this type of relationality. So we specified 3 main co-hashtags, and then we want to to see, okay, which other associations go hand in hand in these particular contexts. So now we want to specify the associations, the co-hashtags for the hashtag quarantine, for the hashtag comedy, and for the hashtag dance. So again, some filtering needs to be done here. So let's create again a new sheet, call it currency. And go into our sound memes and filter the column hashtags by creating a filter and searching filter by condition, searching for quarantine and clicking OK. It will well select again an output for you to analyze. Just select everything, click on Command C, and again input this data in Tag Crowd. Just refresh, paste all your quarantine related co-hashtags, and now depending on the analytical choices you made. So obviously we again are not interested in showing the main hashtag board in the house. But now we are also not interested in showing the second main hashtag quarantine. And because we are creating a diagram focusing on correlations between hashtags, we also do not want to see two other hashtags that we selected. So comedy and dance in my case, and in your case, maybe something else. Yes, let's just specify it. So I don't want to see comedy in here, and also no dancing. Good. And minimum frequency also maybe 5 or something. And visualize. Well, it will return something. Oh, okay, it's maybe not enough because we want to work with, let's say, top 10 main associations in order to create a visualization that is rich enough. In a way, we created it here. So I'm just showing you what should come out of it, which kind of output. So this is our main hashtag, and these are like our co-hashtags that we want to see, and we need 10 of them. So let's just maybe change the minimum frequency to 3 repetitions and visualize. Okay, this is better. And then we obviously also want to show the frequencies, because this is how we are going to work with our data, and we just copy it. Go to our quarantine sheet and paste it. Okay. Well, but this is not the right format, as you can see. We now need to do again some rearrangements. So we select all the text, go to data, and select split text to columns in order to prepare a data set readable for raw graphs. Split text to columns, and it will give you an option of customizing. And now we will just use the expression adapted from Tag Crowd and separate by the brackets, and just click enter. Okay, so now it's separated. Then we want to paste this transposed by going on copy and C, and pasting it transposed. Just let me, sometimes I forget.
I think it's paste special.
Yes, thank you. Sometimes.
Yeah.
Yes. So you paste spatial, paste transposed. Here we are. Okay. And then you delete this one, and again separate it by using split text to columns and specifying again now space and the brackets. Okay, so here's something that's wrong. Okay, so now you will be able to arrange your data by ranking it in accordance with the repetition of hashtags. So just delete this row, call it co-hashtag count or co-hashtag count. And obviously you also have the main hashtag, so insert column. And our main hashtag, as you remember, is quarantine. Okay, so this is like the first step for creating a visualization like this. So we have like the first part for quarantine, and in the same way we proceed basically with the labels. So we return to our initial data set. It's already filtered, as you can see, by hashtag quarantine, and now you want to look at the labels. Sorry, here we are. So it's filtered by quarantine, and now you want to look at the labels. And these are the label descriptions that you select and copy and paste to tag crowd, and basically repeat the whole procedure again, with, you know, specifying the frequencies, copy and pasting, rearranging, pasting transposed, and so on. So this then will result in this type of order, and you can do this with the labels, but you can also do this with Google Vision API entities. So our correlation right now is the main co-hashtag, co-hashtags related to this co-hashtag, and then the content associated with the main hashtag quarantine. And then when, you know, you can repeat the whole procedure for other co-hashtag relations that you are interested in. So, and of course, it's a very long process. So I'm going to show you an alternative way of working with correlations. This requires some GAFI skills. And it's also, you know, it's a lot of copy and pasting also here. In GAFI, you will have less copy and pasting, but more importing and exporting. So at the end, the process is almost as long as working manually and calculating correlations. But just to give you an idea, because this is also how networks work, because what we are creating here is, a correlation that we also usually work with when we work, for instance, with co-hashtags. But for now, so now we are actually working with a network with two types of nodes. We are working with hashtags, and we are working with, you know, Google Vision API labels. So let me just show you the logic behind it. Let's use our sound sheet here, and to import it to Gephi, just go for File, Download as a comma separated value. Okay, and then go to Table to Net, Tools, and choose this file that you just downloaded, and open it. Table to Net allows you to to create correlations and visualize them as a network using a network file. So it transforms a tabular file into a Gephi file, into a network file. So first you will specify the type of network, and it has two types of nodes, as I mentioned. Which column defines the first type of nodes? The hashtags column. And in order to separate it, okay, this I forgot one step. You should actually separate, yes, Gephi maybe is a little bit more labor intensive actually, but if you work with larger data sets, it helps you with arranging your data. So you might want to, in order to work with a Table to Net, you might want to redefine the separator. So again, go for File, Find and Replace, or sorry, I think it's Edit, Find and Replace, Find, hashtag replace with a comma or with anything that is readable for Table to Net, and just click Done. Sorry, I forgot to confirm. So find and replace, hashtag replace with, and replace all. Okay, done. So, and download, please, the same spreadsheet. So here we are, and download as comma separated values. Okay, and again, Table to Net. Choose file, it should be, I think, this one, I hope. One or two. Okay, yeah, this looks good. So hashtags, type of network, bipartite, choose column, hashtags, separate them. You don't want any attributes here. And then you choose your second column, which should be your labels column, and I just have to find it. Label descriptions, and again separate it and download it as a Gephi network. So why is this necessary? This allows you to export data. So if we now open Gephi, and I'm just quickly going to show you how Gephi would create or automate, let's say, the same things that we just performed using manual work in the words cloud. So you just open the file that we just created. And it should be this one, open. It is a mixed file. It has 2 types of nodes. And if we define here the type of nodes by using partition, we will have hashtags and label descriptions, and then we can just apply in order to make this recognizable for Gephi, and go to the attributes, choose partition, choose the type of node, and say, okay, you want to see hashtags only now. And this is where you will see the occurrences count that we have just created, the co-hashtag occurrences count that we have just created using basically the manual work, right? But if you are working with larger data sets, it's a good way to automate it, but then you will have to export this table and repeat the same procedure also for labels. So you can do the same thing in structuring the labels, and again, filtering by the occurrences count. And you will be able, but I think I made a mistake here. It didn't specify the separator. Yes, but as you can see, it's a lot of work. So this is why sometimes I prefer manual to calculate correlations manually. So now, we have 5 more minutes. I will show you what you can do in terms of visualizing our raw graphs data input that we just started to create. So in the spreadsheet where you already have all the analyzed data, just go for raw graphs hashtag content sound and copy and paste these columns here. Okay, copies, open raw graphs, and use it now. Paste your data. And select, in this case, this diagram, visualization focusing on correlations, hierarchies, or proportions. And then it will ask you, okay, how do you want to organize your hierarchy? Okay, and what you want to do is, first, the first row of association are the co-hashtags, then the main hashtags, in our case, quarantine, comedy, and dance, or maybe cats of TikTok, I don't know. And then the labels, okay? And here in the size, and you will find also the instructions here, you can use the co-hashtag count, which will then basically translate into the thickness of edges, okay? So count co-hashtag. Good. And then you can, arrange your, or let's say, beautify your graph here. And I mean, I think I have proposed some options somewhere here, or as in, you can play around with it. I just created this spreadsheet, this visualization, so you can specify the height again and the width, and you can specify the margins, the size of the nodes. An important thing to do is to minimize overlaps in the chart. Okay, and then also a very important thing to do is to use the right color scheme, so that you know, to make sense of your proportions. So maybe 1 more minute left, but we're also almost done. Okay. So the hashtags which correspond with the content of the images, and as you can see, many images focusing on, you know, flooring and wood, many images focusing on gestures, and then the co-hashtags that help to contextualize the image content and tell us a lot about the specificity of our TikTok data set. So basically you see a lot of For Your page and For You. You see COVID related co-hashtags. You see some, you know, stay at home. You see some, well, typical cats and funny and viral stuff. And well, yeah, bored at home, bored in the house. So this is, I hope, one one helpful way for you to analyze image content in relation to hashtag specific contexts of the images. Yes, and the third part of the workshop, I anticipated this actually, but you can repeat the steps basically by using this walkthrough. So, and with this, I am done. Thank you very much.